Okay, so now we're going to talk about integrals where they actually have limits. So these are definite integrals. And we're going to do them a couple different ways. But first of all, so you have a function right here. This function f, which is a composite function because you have g inside. When you have g inside and it's being multiplied to the derivative of g, that's when this whole shortcut for substitution is going to take place. So your limits change from c to b or a to b. Actually, they should be from a to b. That's an a. So they're going to change from a to b to g of a to g of b. And again, we'll do some examples, but just get this down. And then fu, sorry about that, explicit language again, but fu times du. So you did the change of variables, and so since you changed it, your limits are also going to change as well. Let's take a look. We're going to do this two different ways, and you can choose and then tell me in class whichever way you would rather me to do it in class. It doesn't matter, okay? So way number one. First thing is we need to figure out what our u is. So our u is going to be your inside part, so that's going to be the x squared plus 1, and then also you notice the derivative of this is, going to get rid of the x, because the derivative is 2x. So you get du is equal to 2x dx, solve for dx, and you get dx is equal to du over 2x. There we go. Now, we're going to go ahead and rewrite this. So it's going to be from 0 to 1. And you're going to have x times u to the third times, instead of dx, I'm going to write du over 2x, like that. And then nicely, you notice these x's will cancel. And then this 2 will come out front, so it becomes 1/2. So let's just go ahead and rewrite that as 1/2 times the integral from 0 to 1 of u third du. Now, you notice now it's in terms of u. That means these variable or these limits need to change. If I'm going to keep it in terms of u, even after I integrate, and those are the values I'm going to plug in, upper minus lower, I need to change them. And so what I do is I do this in green. I'm going to take this part. If u is x squared plus 1, right now they are in terms of x. The 0 and 1 are in terms of x. So plug, for example, your lower limit is 0. And so in terms of u, your lower limit then becomes 1. And your upper limit was 1, so then you would plug 1 in. And your new upper limit is 2. So these green, that green 1 and 2 are your new lower and upper limits in terms of u. So when we integrate u to the third, that gives you, so the 1/2 stays out there, and that gives you u to the fourth over 4 plus c Okay, then when we simplify this, actually no, there's no plus c, my bad, got distracted here, my dog just walked into the room. She's got the runs, gotta watch out for that. So anyway, our limits, we don't have the plus c since it's a definite integral, so we gotta use our limits. So it's going to be upper limit minus lower limit, so it's going to be 1/2 times the quantity. When you plug 2 to the fourth in there, you would have 16, so you'd have 16 over 4 minus your lower limit. So when you plug 1 in there, that'd be 1 to the fourth, which is 1 over 4. And then when you simplify that, that gives you 15 fourths times 1/2, and then that gives you 15 eighths. And that's your final answer. Now, for the next one, we're going to keep, we're actually going to, I did them opposite actually, so this up here, we kept the limits and changed them back in terms of x, so I switched them, my bad. So then down here, we're going to change it back to x. Up there, we kept it as u. Kept it as u. Here, we're going to change it back to x. So we're going to do the same thing. So when you get to this point here, where you have u to the third, so you'd have 1/2. Everything is the same up to this point. Now our limits were 0 and 1, so we're going to go ahead and integrate this. This is u to the fourth over 4 times 1/2, and this has limits of 0 to 1. Now, in order to use these limits up here, we change them. These are in terms of u because we plugged it in up here. But if we want to use these limits, all we need to do is plug x squared, what was it, x squared plus 1 back in for u. Then you can plug in your 0 and your 1. So you can see, oops, too far. When you plug in your 1, so you'd have 1/2. 1 squared plus 1 is 2, so 2 to the fourth, which is 16 over 4, minus 0, so you'd have 0 squared plus 1, which is 1. 1 to the fourth is 1. So you would get the same thing, which is 15/8. Okay? You get the same answer for either way, just up here we changed everything in terms of u and kept this as u to the fourth over 4. But you're doing the same thing. If you think about it, you had to plug the 1 in and the 0 in up here to change these, and so you're doing the same thing, it's just in a different order. Students most of the time, I'm finding that they like this method where you just change, so you would plug u function back in there and just keep your limits the same. That's what I'm finding, but whatever you want, we can do. You have to be familiar with both ways because they're going to ask you questions on those. Okay, let's do another one. Again, do these on your own first and then come back to the video and see how you did. So our u value again, it's going to have to be the in part of our composite function. So u is 2x minus 1. Find the derivative. Du is equal to 2x dx. And so dx is equal to du over 2x. Alright, so we're going to go ahead and do 1 to 5. X over the square root of u times, we're going to plug in, instead of dx, we're going to plug in the du over 2x. And these x's cancel out nicely, and so everything is in terms of u. So again, this is where we could break off, and if you want to keep it in terms of u, then change these variables. You would plug 5 into here, so you'd have 10 minus 1, so then this would change to a nut. And then you would plug 1 in here, you'd have 2 minus 1, that would still be a 1. So it would be from 1 to 9 instead of 1 to 5. But I'm just going to keep moving along. So you'd have the integral, let me go down here, you'd have the integral from 1 to 5. Instead of the 1 over the square root, so I'm going to bring this 1/2 out. And instead of 1 over the square root, I'm going to go u to the negative 1/2. It's easier to look at that and integrate that, because now if we integrate that, come down here, you'd have 1/2 times the function, so you would add 1, so that'd be u to the 1/2 all over 1/2 from 1 to 5. Now again, if you want to keep this 1 and keep that 5, what you need to do is go ahead and change u into 2x minus 1. But this 1/2, just real quick, this 1/2 becomes 2 over 1, the product. So you'd have 2 over 1 times 1/2. This is a constant, so you can actually bring this out. It doesn't affect the limits at all, because these, the 5 and the 1, only go into your variables. So you can bring that out and they cancel. So really all you have is the square root of 2x minus 1 and you're going from 1 to 5. So plug your upper limit in, that's 5. So that would be 10 minus 1, the square root of 10 minus 1, minus your lower limit, that's going to be 2 minus 1, which is 1, so the square root of 1. So you'd have the square root of 9, which is 3, minus the square root of 1, which is 1. So then you would have a total of 2. So if we look at this, the next thing we're going to talk about are even and odd functions and integrating them. This is extremely important concept because in some problems they won't give you the function or give you certain tidbits about the function, just enough to know that it's symmetric, whether it's symmetric, even, which is vertical symmetry, or by the y-axis, or odd is the y equals x symmetry. Okay, so there is a difference. So if a function is even, if you know that this function is even, and you're integrating from negative a to a, so negative 4 to 4, whatever, so these are opposites. Okay, they have to be just opposites. So if this is negative 7, then this is positive 7. Very important. So if you're integrating and you know it's symmetric about the x-axis, then hey, you can just go do half of it. So instead of going from negative a to a, just go from 0 to a. Okay, and this is a huge shortcut because plugging 0 into a function is a lot easier. So just double it when you go from 0 to a because the other side of the function is going to be the same. However, if it's odd, what that means is if it's split, then that means there's just as much below on one side as there is on the other side. And so then that makes it then an odd function. Okay, so you can check it out as you go through the homework. If you realize something's even or odd, remember, look at the exponents. If all the exponents are odd functions, then it's an odd function. Or if all the exponents are odd, then it's an odd function. All the exponents are even, then it's an even. If they're mixed, even and odd, then it's inconclusive. All right, and then also sine and cosine. Okay, one of them is odd and one of them is even. Sine is your odd function and cosine is your even function. So just remember that. Cosine is even, sine is odd. And I think that's going to help us as we do this one down here. So if you haven't already, go ahead and try this one and then come back to the video. So here you go. Here's an example of a function where you really couldn't integrate it at all. But now, okay, so if this is on the AP exam, you can't integrate this. You're going to waste your time trying to use substitution, all that jazz, because it's not going to work. Because you got two things going on. You got this product and you got the entire sum of two products, and these aren't even the same. So now let's determine if this is going to be even or odd. So but the problem is you got some evens or some odds, so it's really, you can't look at it and tell. So it's in a sense inconclusive just by looking at it. But remember, the test that you do is you plug a negative value in. Okay, so if you plug a negative value in and then your output is positive, that means it's even. Like x squared. Okay? If you plug a negative value in and your output is negative, that means it's odd. So let's test it. If we plug a negative value, that means you would have sine to the third of negative x times cosine of negative x. I'm going to erase this. Plus sine negative x cosine negative x. So now just go through and try to figure out is your outcome going to be all positive or a negative outcome. So now if you look at this, on this side, this is a negative, this is a positive, then you're going to be adding them, maybe a thick old plus sign. This is a negative, and this is a positive, so a negative times a positive is a negative. Negative times a positive is negative, and so then that means that when you would plug a negative in, your outcome is negative. Okay, so does that imply even or odd? Good, odd. So if it's odd symmetry and your bottom, your lower and upper limits, okay, are opposites of each other, then that means that your area is 0. So just remember, on the AP exam, you get a problem like this, looks impossible. It really, it pretty much is. You just have to be able to recognize. First thing you should look at, okay, are the limits. Okay, if the limits are the same, or I should say opposites of each other. Okay, and then right away you should say, whoa, is that even or odd? Because I can answer this question really quickly if those limits are opposites of each other. The absolute values are the same. Okay, so that concludes everything for the integration by substitution. So the first video talked about doing indefinite integrals. Here we talked about definite integrals, which is just basically one step further and plugging in your upper limit minus your lower limit. And remember, we talked about two different ways to do it. It doesn't matter if you plug in, keep it as x, or change your limits to y. It doesn't matter. Okay, just choose one and go with it, but be familiar with both of them because you're expected to know both of them for the AP exam. So maybe practice half and half. And then after this, do whatever you're most comfortable with. All right, good luck.